Hi everyone, we're back, and I cleaned up the truth table a little bit more because it was looking rough, and I went over time, so I wanted to make sure. So this is part 2 of 3.6 lecture. We left off at doing this truth table right here. If you notice, I filled out the columns on P and Q, and now I need to, I started from left to right. I am taking this statement right here. I know I crossed it out in the earlier videos. We're not worried about this statement right here. And I'm evaluating this truth table right here. So I started with P implies Q. And I know there's only one case where it's false, and it's this case right here. So I go ahead and I find my lie, and I fill out the rest of the truth. Right? These are probably the easiest way to do this. Then, once I'm done with that, I look at the bigger statement to the left to right, which is my P implies Q and P. And since we're using and right here, I know there's only one case where this is, I can look for my falses here because there's only one, they can only be true if they're both, this statement, P implies Q and P are true. So here, where I find that's not the case, where I find that's the case is right here. My first statement, T and T, which is true. Here, P implies Q is false. Here it's true, so this is false. We have another false, and then we have another false. So this is the case where it's true. Now, if you notice, I have these little tiny trues and falses because Miss Coco makes mistakes with these all the time, especially when she's trying to teach it. So I write it down previously so that I wouldn't make a mistake. And when I get to my final value, my goal is to see whether or not all of the final result are true values, because that would be a tautology, and that would make it a valid argument. So let's cross our fingers that we have a valid argument here. So here we have this statement. In this case, the first row is true and true, so this is a true. Because P implies, here it's a false and false, so when we have the if-then statement, this is true. Here, this is false and true, which is true. And then we have false and false, which is true. So, we do have a tautology. And we can say, because the final column indicates the conditional statement that represents the argument is true for all possible truth values of P and Q, the statement is a tautology. Thus, we can say that this argument is valid. All right, so we would say that this is a valid argument because of this final result. So that's a final, that's an argument. Now, I promised you, I said that you always will do the same steps to figure out whether or not a truth value of an argument is valid. So here are the steps defined right here in your notes and in the book. Your first step is to always assign letters to your if-then statements in the arguments, to each compound statement. Then you express them symbolically, and you form the symbolic statement of the entire argument by writing the conjunction of all the premises. So conjunction means and, which also means that little upside down V. You have to use the antecedents and the conclusion of a conditional statement with the conclusion of the argument as the consequent. Basically, it's this. P implies Q. And then just like we did above, that's what that means. And then finally, you complete a truth table for the conditional statement. And we look to see whether or not it's a tautology or it's true in all cases. If it is, it's a valid argument. If otherwise, if you have a false, that means it is invalid. So here, let's see another one. This one is the case of using negations. And we're going to do this one really fast. So we want to determine if this is a valid or invalid argument. The first premise is I can avoid sweets. I can avoid the dentist. So this is if I can avoid sweets, then I can avoid the dentist. My premise 2 is I can't avoid the dentist. And then the conclusion is, remember that line signifies that I can't avoid sweets. All right, so our first is to let P represent I can't avoid sweets. Q is I can avoid the dentist. So then we say, okay, so my first statement is, my premise 1 is an if-then statement. P implies Q. However, if you notice, they negated, for the second premise, I can't avoid this sentence. So it's actually a negation of Q. So we say not Q in this case. And if you notice, the conclusion is a negation of P. So we say I can't avoid sweets or not P. So our final conjunction is we take this. So this was our second step, the symbols. The third step is to write this big statement right here. So what we do is we take P, the first premise, P then Q, parentheses, and, or not Q, chunk it out, because the conclusion symbolized by this implies arrow is not P, which is exactly what is written down here. So I'm going to erase some of this. I just wanted you guys to see it by hand. So basically, this is our first premise, conjunction. Second premise, arrow means that we're coming to a conclusion, and then this is just our conclusion. So this is like the line right here, right? This is our conclusion statement. And then you could rate a tautology to see if this is a valid argument. So how you do that is, I already did it. It's in, let's see here. If it's a valid argument, you do this PQ. Then, because you have knots, you have to identify those first. And then you start with your left-hand side, P then Q. Your not P, or excuse me, P then Q and not Q. And then what else goes here? Pause and see if you can fill out the rest of this chart. Okay, so if you came back and you said my next statement would be this, you are correct. Let me finish it out before I say that. This is P implies Q and not Q implies not P. If you wrote that, you are correct. And go ahead and pause if you haven't done so already and see if you can construct the truth table for this. All right, so we're back. And if you got all T's for here, you did it correctly, and this is a tautology. And we would say that this is a valid argument. All right, that's an argument, guys. I'm trying to be aware of your time. So it's a valid argument. That's a little period right there. Now, here are the forms of valid arguments. So if you noticed, we have these cool patterns with these things. I'm going to erase some of this. If you notice, this previous pattern was P implies Q, not Q. The conclusion was not P, right? Well, these are patterns of arguments. Our previous one was P then Q, then P, conclude Q. So these are actually patterns. And there are valid argument forms that say that once you turn everything into a symbolic, you turn words into symbols and then take them into your symbolic form. If the first premise looks something like this, the second premise looks something like this, then your conclusion is Q, then this is a valid argument. The same thing, and it's called a modus ponens. I think I'm saying that right. The second says that if your first premise looks like this, the second looks like this, and your conclusion looks like this, then this is also a valid argument if you put it in a truth table. Also, this, if your premise looks like this, second premise looks like this, and your conclusion looks like this, then it is also called a disjunctive syllogism. And here, this is reasoning by transitivity. This is saying that if you have if P then Q, and then your consequence, this is a big one we're going to use here in a second. This is a big one. So this says that if you have a consequence that goes to P, and then your P becomes your, if you have a conditional that's P, and your consequence Q, and your Q becomes your new antecedent or conditional, your hypothesis, and it ends with R, then you can take P and say that it implies R as your conclusion. So that is called reasoning by transitivity. And that is a big deal here because we're going to use that. So this is your premise 1, premise 2, and your conclusion. So please remember this because we're going to use it for one of your objectives. You have to create a conclusion using reasoning by transitivity. All right, so invalid forms, this is called the fallacy of converse. This means that if your premise 1 is if P implies Q, premise 2 is Q, and then your conclusion is P, it's false. It's invalid because your truth table has a false. Same thing here. If you notice, you just flipped them. P goes here, and then you end P. Q goes here, and then you end with P. That's a converse. And this is the fallacy of inverse. All right, so this is your premise 1, premise 2, and conclusion. So these patterns in symbolic forms are invalid arguments, meaning they don't have a tautology as a truth table. All right, so I'm going to go on to part 2 of, please watch the part 3 of our